a friend of mine is working actively developing joern, I guess. If he would know that I use CodeQL, he would be very disappointed and angry at me because he says CodeQL is shit and joern is the cool shit. And so now having, a CodeQL example, let's see if we can do the same thing with joern. I know nothing about joern. We now go over the documentation. Here's the research question, okay? There are different ways to test for access control issues, right? But we have here the source code. And it would be very helpful for me to very quickly run a query that figures out all GraphQL resolvers that do not have, for example, the authorization check. This is a research question I have. I can even do it by hand, like that's what I would be doing by hand. Okay, there are just a limited amount of resolver files. Okay, there like is a dozen or so, maybe 20, or I don't know how many these are. Not that many, right? I can do this by hand. I can open this one and then I can go through quickly. Okay, this has it. Let's go out. Next one. Has it, right? But I'm looking for one where they are where they forgot it. With that, it could be a bug. It doesn't have to be a bug, right? There are often also resolvers where you don't need to be authorized because it carries some public information or so. It feels like if I could learn some basic CodeQL, maybe it's very easy for me. Give me all resolvers where there's no authorization check. And then I can go over the few that I found to see logically if this is a bug or not. Is this meant to be public or was this forgotten? Welcome to the documentation of the code analysis platform joern. For a high-level overview, please check out joern.io. joern is a platform for robust analysis of source code, bytecode, and binary code. It generates code property graphs, a graph representation of code for cross-language code analysis. Code property graphs are stored in a custom graph database. This allows code to be mined using search queries formulated in a Scala-based domain-specific query language. joern is developed with the goal of providing a useful tool for vulnerability discovery and research in static program analysis. So immediately, I guess we can compare it a bit to CodeQL, just to make maybe this transition. I mean, not that it's like a transition. It's not like I'm experienced with CodeQL, but for me, it helps to kind of like compare the similarities and differences. So first of all, like the supported languages are kind of similar. However, it does have using based on Ghidra, there's you can even work on assembly. You can even work on JVM bytecode directly. There's also JavaScript. I do wonder if TypeScript will be an issue for us because the source code is actually TypeScript. So if that would be an issue, then we have a problem already. But then we will find another example to work with. And then also this graph is stored in the custom graph database. So that's kind of the same with CodeQL as well, which might be a confusing step. Why can you not just search immediately on a source code in order to make this actually performant? Because graphs are these kind of languages are very expensive. So you first analyze all the code and it creates a database that you can then use the query language to ask about certain properties. So it's not like grep or just searching over the source code directly. It's you first turn your code into into a different format that then, with all the relationships and all that stuff that you can then, yeah. And then also I know already that joern also offers a Scala-based language, like a shell that you can more dynamically query and work with. I found it a bit annoying. With CodeQL, you write your query and then you need to run it. It needs to be compiled and then you're waiting and then it results. I don't know how fast joern is, but it's like a interactive Python shell kind of thing, where you can then start to write your queries, which for the purpose of security research on a specific code base is nicer. I feel CodeQL, the idea behind CodeQL is more with the motivation of GitHub, which is large scale scanning across whole GitHub, scanning all repositories on GitHub or something like this. Because, you develop a query and then it gets compiled and everything is very efficient and architectured in a way that then this query is then used by tons and tons of projects. While For me personally, I more work on individual programs. For me, it's more like, okay, I have this question about the code that I want to have answered quickly, and CodeQL is maybe a bit too slow for this iterative process. And so I hope that with joern, this kind of iterative research process where, oh, right, there's this function, let me quickly write like in a shell, bam, 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 and then I have the result. That is kind of my hope, but no clue if it can fulfill this hope. Installation. Installed pre-built binaries. So do we want to use pre-built binaries or do we want to take GitHub? How far behind are the releases? So the last release was 2 hours ago. Okay, 8 hours ago, 20 hours ago, yesterday. Okay, it looks like the releases are constant releases. So let's use the pre-built stuff. Okay, so we get the install script, we make it executable, and let's install it. Enter for the latest version, let's go. Oh, while this is downloading, should we check the statistics on the video I released? Distraction over. Distraction over. Let's go back to joern. How long was this detour now? At least it installed completed, okay? So it's in bin joern and we can test our installation. Okay, joern. Okay, building from source code. We don't need that. Configuring the JVM. I guess we can give it a lot more gigabytes because like how much did I gave it a lot of gigabytes, so we the VM, so we can set these Java options as well to 20 gigabyte. That might help. All right, quick start. Here they do an example with a C program, but we want to try it out on the Node.js stuff. So let's see if we can just call import code, but on our project. So where was our project again? So this is our import path. And let's see if the import path, and then project name, red eye. Let's see if that, okay, this failed. Okay, I forgot the quotes around the path here. There we go. Uh-oh. Okay, is this error problematic? What is this? It couldn't generate CPG for cache TS. So just to understand why this failed, maybe, let's see what this cache file is. It's a cache node, entity cache manager. Okay, is that just a type definition? No, it's just a class. It does have some code in here, so I guess it's a bit unfortunate that it failed to read this file, but I'm also kind of curious, where is this used? Oh, it's not used anywhere, apparently. Cache manager. Okay, the cache manager is used in here. Yeah, I don't know. Like this could be maybe a problem, but maybe not. If like this function couldn't be parsed, as long as it's like kind of forgiving and was able to still do with a lot of other stuff, that might not be necessarily problematic. But of course, it would suck if it includes, like if we would want to like research something about this cache stuff, obviously I guess now this would fail. Key not found name, no such element exception. Key not found name. So I wonder, name doesn't show up in here, so the error might be more related to like something like from the parser code itself. So it's not like something, I thought maybe we can like add maybe a name property or something. Let's move on. Okay, but in the end, it seemed to have worked. We apparently have a graph with 27,000 nodes. So how do we work now with this? Querying the code property graph. CPG, code property graph. Okay, we have these many nodes. You are ready to analyze your first program using joern and the code property graph. Code analysis in joern is done using the CPG query language, a domain-specific language designed specifically to work with the code property graph. It contains practical representations of the various nodes found in the blah blah. The top-level entry point into a code property graph is the CPG. If you evaluate CPG, yeah, okay. Rest assured, a lot is hidden behind that simple statement. You will discover the full set of commands in time, but for now, you should learn a helpful joern trick, tab completion. In the joern prompt, type CPG, do not press enter, but instead press tab. Okay, CPG dot, and then we can see what all of it is available here. Tab completion is available for all query language directives and top-level commands. For more Descriptive assistance, use the help command. Now that we have a good set of basic commands and a code property graph loaded into memory, let us return to our program and the problem we want to solve using joern. To reiterate, the problem statement is show that an input exists for which the program always writes a string to standard error. There are two parts in the problem statement. Does the program write anything to standard error? And two, if there is a call writing to standard error, is the condition on a value passed in the argument, what is the condition? joern makes answering both questions easy. To answer the first one, whether the program writes anything to standard error, we can search for nodes of type call, and then use the argument step to only select those calls which have connection to the nodes of type argument, followed by the code std error, which selects only those nodes that have the string standard error as the value of their code property. So I wonder, so I do wonder like decorators, how they show up now in here. I guess they are functions ultimately. I guess here we talk more about like, or is there decorators in there? But decorators I feel like are something language specific, and this code property graph seems something more general. Whatever you use, anything ends up as a code property graph. So I assume decorators would be functions as well. Is there something like function specific, like f? There's a for block. So I guess we are also looking for calls. So here, the CPG was, we look for calls and then arguments where the argument contains std error. Is this correct? So we look for calls where one argument contains std error. Okay, so I guess if we do try to replicate the CodeQL statement, we want to maybe find now all the decorators or the function calls of the name query. So I wonder, can we do call and then can we check like if the name is like query? How do we know if we found something? Like if this query is now empty. Oh, toList. We can call toList on it. It's an empty list, so this didn't work. However, the decorator also has an at before it. Does that? It's also an empty list. Okay, let's let it list all calls. Okay, there are a lot, but maybe we can get an idea of like what the names are. By the way, can we do like list and then only like get like a limit or something? ToList 5. I guess this is the fifth element, but this is still helpful because I just wanted to see like what are the properties of like what is like read from call. The code is like an actual string of the code that this part represents. Like this is a pretty ugly one. Like, but here is, for example, the require crypto, I guess, import code, for example. And then we have a method full name and name. Name is more field access. So this reference like this dot encrypt. So this is a field access and this is the name. So I guess the more hacky way, which is okay, I guess, if we do code and then say query toList, what show? It's still empty. Let's open one of these resolvers. Why? So if we look at all calls or anything that is a call, why is the field, is a field access a call? Is this like a get this field? Is that why it's a call? It's like static dispatch. In here is definitely a call, I guess. Find, for example. So if we do code find, would we find then it's also empty? Okay, if we find crypto. Oh, okay. I guess this is like very strict. It's not a fuzzy string match. How can we do like a fuzzy string match? CPG file gets you everything in that file. You are right. That's a good way to think about this because then we can see like what's in there and then we can explore it. This is the file and then toList. Okay, maybe I misunderstand how this works. Why is this now also empty? Oh, the full path. But I don't know what the full path is relative to what. Okay, I guess source relative to source. So we can do this. But there must be also like a fuzzy string match, right? Like there must be. All right, okay, we found one file. And now in that file, we look for all calls. Okay, no, that failed. Call does now not exist. I was hoping like if we have now the file selected, now we can only select all the calls for that files, but that's I guess not how it works. Maybe there's a get calls or something, or get children, or collect. I mean, collect or something like that could maybe do it. Okay, okay, then maybe that's not the way how to do it. I want to figure out if there's a fuzzy string match. So maybe they mention it here. IST parent. Okay, that's also good to know. Let's scroll here a little bit over maybe traversal basics. Method. Oh, there's also method. Maybe method makes more sense for JavaScript. This query returns all names of methods present in the code property graph and can be dissected as follows. Like this is maybe again better for nice. All the methods now. It's not sorted. I just quickly want to scroll over because maybe we can like find some useful stuff similar to list. Maybe there's a way to like sort it in a certain way or filter it. For example, I would like to know if there's like a fuzzy match because you can do things like here, for example, you can get the file. So file by this name. How can I, if I don't know the exact path, is there still a way to do this? Or could I get all the files that have resolver in the name? Because this can be useful because usually all the GraphQL resolvers have a file name based with resolver. Is there like a fuzzy match where I can say like when this is contained in that string or something like this? So that would be kind of useful. Add a wildcard to the file name. Okay, that's a good point. Let's try it. Okay, this caused, oh, it's a regular expression. Okay, that makes things, of course, easy. There we go. We find all the files that have resolvers. Nice. So let's go back to this other example. That's good to know that these are regular expressions. That's, of course, very powerful. Let's go back to, because we looked, I thought maybe because these decorators are they are function calls, right? I guess, I don't know. Like, so I imagine they might be turned into call nodes. So I wanted to search for calls that are called query, but it's empty. So maybe it's just, maybe it has the parentheses to it, or maybe it has the at in the front of it. So maybe, yeah, with fuzzy, okay. No, okay, we found now these function calls here that have query in the name, but these are not the decorators. But okay, so these are actual function calls now. It's good to know call resolves that. But the thing is, again, like we don't know how the backend turns a decorator into this graph database. So yeah. Do you hear the barking outside? Some dogs have a lot of fun right now. Instead of a call, they are annotation nodes. That sounds reasonable. That sounds like a reasonable guess. If there is such a thing as an annotation node, but I assume you tell me because there is one. Okay, there's an annotation node. We can also do toList to see like index out of bounds. Okay, there are no annotations, I guess. It's empty. Identify. Maybe it could be easy to just look for, it is probably an identifier, right? Lots of things are identifiers, but so we can find, so here, this require, for example, is an identifier. So let's see if we can find an identifier that is called query. This is the type hint. So this might actually be one of those query. Query order is obviously not what we are looking for, but they are really called, okay, these are type hints, type GraphQL query. So this is definitely the correct query. And they are really called query. How does regex work? I want to do an OR. Is that how you write regex OR? No, right? Did this work? No, it worked. That's how you write ORs, apparently. Okay, cool. So now we find all mutations and all queries. Let's see, can we do like .file to find all the files where they are in? Now we find all the files where these identifiers are from. And we can see they are all referred to as these resolver files. So that is obviously absolutely correct. So in CodeQL, these decorators were like on the same AST level. In the abstract syntax tree, they were on the same level. So they were basically siblings to each other. So to check if there's an authorized decorator, we went from the query to the parent, and then we looked if any of the children were authorized. I guess like if you do like AST parent, or do they maybe even have AST sibling? AST children, AST parent. No, okay. So we go up to the parent. So what do we get now? What is the parent of it? So here's an assignment, query mutation, query require. No, wait. These are the wrong ones, right? No, wait. Var query require. Oh, these are. Is this as import then? Is this line turned into this here? I guess so. I guess like this compiler or transpiler or whatever, like somehow I guess turned this into these import statements. So actually we don't want these import statements. Maybe we don't want then identifier. Okay, let's see what else do we have. Identifier, if block, import, jump target, label and property. I don't know, what is a label? Do you have to also analyze the transpiled JavaScript, or could it be easier to just look at the TypeScript source code? I mean, the code that is in here, that joern did. Joern used something to parse the code. This is the code here, right? Yeah, so I don't want to look at the transpiled JavaScript. I'm looking at the TypeScript code here. But I guess maybe you're right. Maybe we should. How do you look at, like, how do you, I don't know how TypeScript works. Is that how it works? TypeScript is transpiled to JavaScript. Is that how it works? So is there a way to like easily get the transpiled version of that? Check out the distribution. Yeah, okay. Yeah, makes sense. Of course. Oh my gosh, am I dumb? Of course, like TypeScript is transpiled to JavaScript because in the end, of course, you have to. For example, you have to run it with Node.js or in the browser. Of course, it transpiled to JavaScript. I'm such an idiot. Wait, are we in the correct application? Server, source, and then we have here resolver. Is there like a beautify, prettify? There we go. Okay. Yeah, now we see these require calls. That's, of course, very useful. So where in here does the query show up? Decorate. Oh, there's a decorate function, apparently. And where's that closing? What? That's like a weird... It goes up until here? Holy shit. Okay, but I guess this helps us a bit. So we should find it with call, right? Because it's clearly a call here. But this also makes it very difficult to find the author. Oh, no, wait. Okay, these are separate. Like, where does one end? Okay, this is the end of the query. And then this is the other parameter. But I feel like, yeah, these are all separate, right? These are the three. If you look in the beacon resolver, are there three? Yeah, there are these three. Okay. And then they are like a... Okay, so if we would have query and authorize. So query, that's really, oh, it's another. Okay, so decorate gets passed in a list, including their decorators. So this is a list. First one is the authorized and the second query. So if we find this correct query call, we could probably go like the other argument, no, not arguments, to the list that contains all of that. And then, yeah, we check if authorized is also in the list or not. I guess that's the way to do it. But why does this not show up as a call? Function is not something that exists, so it should be call. Let's try this. Maybe I did something wrong earlier. So if we do like query, no, we find these create query builder. We need to look for a function arg that is a list and then a list value to match the author. That would be definitely the way. Like maybe we look for decorate and then we go into the argument, which is a list, the first argument. That is one way. But I don't understand why we cannot look for this function query and then go out, because decorate might be used in other things. Like it's a graph, right? Like somewhere we enter this graph and then traverse the different nodes. And whether we come in from decorate, go then to its argument and then the list inside of it and then the decorators shouldn't be different. Like maybe there's a performance difference. Like I don't have like intuition about querying a graph where one way is definitely better than the other. I don't know, but I would assume for this small program, it's probably good enough. But yeah, I guess it still could be a good test to see if we can find all the decorate functions. Also an empty list, there are no calls. So maybe we misunderstand what call is for. What else could it be though? Method. Maybe it's method. There are no queries and no decorator either. Does joern compile the TypeScript though? Sure, the import thingy is getting transpiled, might be happening because CJS versus ESM imports are both JavaScript related. So if we look into the joern documentation in the supported language, it says here that it uses GraphQL for the JavaScript. So don't ask me what this does. Okay, there's a GraphQL JavaScript implementation. It's a ECMAScript compliant runtime. It's standard compliant. So it uses that. Let's see, GraphQL TypeScript. Maybe we can learn what it does. Doesn't immediately show up about TypeScript. So I don't know. I don't know how it works. GraphQL is one of the worst ECMA implementations, apparently. Yeah, well, I mean, there are not that many, I guess. And joern is based on Scala. So I guess they chose a Java backend that, you know, more easily integrates with what they already have. It is, however, already, like this is already turning me a bit off for using it more, because I'm reading the TypeScript, of course, and like seeing how crazy TypeScript is then transpiled to like this kind of JavaScript. I mean, or even Node.js, I guess decorators, or how decorators, I guess, are compiled. This obviously makes it, now I look at the code, now I need to reason about how it was compiled, you know, it makes it a bit, it's not necessarily a problem if I can easily traverse the graph in here and kind of figure it out. But yeah, you might have to feed it the compiled code for it to work properly. Look here, these var require GraphQL. There is no, I don't think that there's like, require, like there is no var query equal require. So this is already, like, it already uses compiled or transpiled. Like, I don't know, like, what it did behind the scene. So they use this backend to parse the code and, I don't know, pull out all those nodes and the graph connections and so forth, and then import it into the into their database in their graph database. And it could be because, you know, the support is considered medium majority. It could be that, you know, on this kind of TypeScript stuff, I don't know, it's losing all of that. You know, maybe the decorators are just gone. Maybe they are just not in the database. I wonder how we could figure that out. Yeah, I have the feeling it only registers JavaScript stuff when it runs into decorators which do not exist in JavaScript. It might just skip over them. Yeah, some stuff like this could definitely happen. I wonder how there's a way how I could figure that out. But we could do all, which probably should give us all the nodes, but it's very long. And so I want to figure out, like, I don't know, how I can pipe that into a file and then grep over it. So let's maybe, I guess, CPG to load. Oh, we should have, I guess, saved that graph somehow. Okay, my history doesn't go as far back anymore. Crap, maybe I should have taken notes. So again, if we execute it like this, did it maybe remember the whole history, or are we fucked? Oh no, it remembers. Okay, cool. Another option could be to transpile the TypeScript to JavaScript and then scan it. Basically scan the dist folder. Actually, let's try that. We can, I guess, scan over the dist folder. So instead of this input path to import code, I guess we could target the dist folder. Or copy path. Okay. And then redeye.js maybe. Joern docs only list JavaScript support. Yeah. Okay. Now we also found a lot more nodes. I guess it makes sense because they are two, like one is compiled and one not. Okay. Okay. cpg.call. And then we look for query. Okay, so here's the query, here's the query. So these items and list, yeah, these are definitely, yeah, type GraphQL. These are definitely those calls to query. If we now go AST parent, push, are these all these push? I mean, makes sense because like adding to an array is a push. I don't know where this code is coming from, but I guess these are these array pushes. Crap, I thought we would maybe get, does anybody know internally, like in JavaScript, when you define, like when you make a list like this and the actual like internal, like the EVM or whatever, or no, not EVM, but I don't know, the JavaScript VM or something. I guess it depends on how GraphQL does it, right? It's very likely that if it encounters like this, it compiles it to like an internal bytecode. Yeah, so it could very well be that is then in the bytecode in the internal VM or whatever, I don't know, whatever it's called, in their JIT compiler maybe, I don't know. It's then turned into pushes, which is of course annoying. I guess there's a way to find all the other pushes. If we go, no, wait. Okay. Here now we have the list, an array sequence. This is the code block. What was it before? It was the call. Okay, now we have a code block, and this code block is actually this this whole list. Cool. That's actually pretty good. So if we now ast children and then ast children again, now we should have the calls again. So in there should also be these other decorators then showing up. Yeah, so here's the query for, yeah, okay, maybe I scrolled too high, I'm not sure. Okay, yeah, so in there are the other ones as well. And now we want to do like, not have something like, I don't know. Can we do like, can you somehow get all the calls? We tried this earlier, right? From ast children is an ast node. Not is a function you can use. Okay, so it does find calls, but it also can we somehow say I only want the calls? There must be a way, because now this gets us, ast children gets us all the different literals, calls, all the different types, and we only want to restrict it to only the calls. Is there maybe like type call or something? Is call, oh, is call seems more like than to be used like as a response. Okay, this gets really just all the calls. Nice, thank you. In my head I thought, okay, it checks for each of them if it's a call or not, and then it will return us basically a list of booleans, true or false. Okay, cool. So we have all calls, and now I guess there was something like not contain, or no, I feel like this is wrong. I'm not sure if this the logic is, if this is the correct logic or to build this graph. If you do like not, this not wants a parameter. Does it want a string? Type mismatch. It wants something else. So is not, so you would do maybe CPG call and you say not authorized. Like no! Type mismatch. Okay, I thought maybe like we get now all the authorized and we make sure that this call is not one of those calls in that graph. But maybe not in. Is there like a not in or something? Okay, maybe I should pull up like some documentation about this. Okay, if we would have continued reading over this kind of stuff, we would have learned that there's regex. Code not. Okay, so is call not. Is there maybe an is call not? No, okay. Oh, is call takes also a regex. Yeah, I don't know. Like even like if we say like and is not is not also authorized. If we say this here, all the calls that are not authorized, that are not called authorized, right? Like we select all the queries, we go up to parent, we go down to the children, and then we get all those that are not authorized. That is not the answer to our question. Somehow we want to get all queries, but their parent, like, you know, like I feel like the logic is a bit different. Okay, here's a filter. Okay, so here they filter all calls, so they take the node and then filter. This is more like what we want. So we would want to do dot filter, and then we would get call, the call, if we go into the parent, and the parent, and then the ast children, and then the calls, and now we want to like say does not contain. Now, like, how can we say like does this return a value, or like there's count? Does this return us the value? And then we do like count equal to 0. Is that it? No, it's empty. Can you just check that the set is empty? Yeah, that's what I was hoping for with, let's see. Let's do CGP call query and then count if that returns what we want. A list with 24. Can I do like equal to 0, equal to 21? False. Okay, just like filter, the where step is a filter step. This documentation, right, my friend? That's why I used this kind of emoticon. Which continues traversal for all nodes which pass its criterion. The expression representing the criterion takes in one argument that represents the traversal of the previous step. It returns another traversal that includes all nodes from the previous traversal, for which the criterion returns a non-empty traversal. So you'd like to query for the program again for our call nodes which have exit as the value of their name property and return the value of their code property in a list. So here we did filter node name is exit, and we got the call to exit. Here we got the both calls to exit by filter and then .code. And then down here, this is the same output. Somebody wrote this output by hand. Look at here the capitalization of the L's. Somebody copy and pasted or wrote this by hand wrong. Where doesn't check for Boolean, unlike filter, right? Oh, you're right. Filter wants a Boolean, while where if it returns a non-empty traversal. So I guess that is actually useful for us because, let's see, if we do like call query and then parent child is like, can we get all authorized like this? Okay, this is already a problem. Is call. It's 2 layers because we went also 2 layers up. So I should do like this. Also empty. Did I misspell authorized? Okay, so there are, okay, maybe I should do a fuzzy match. What if I remove 1 layer here? It catches these pushes instead. Why did then this call match everything, but this call not? So if we do like this and then file, we get all the files that have authorized. So there should be no operator resolver in here. And that is correct. Okay, so kind of like then we almost got it. So if we do now, so we do CPG call query, where we get the query, and then we check if that returns something. Oh, if you do the underscore, it's not an arrow function. There we go, .l. Now we find a few. Oh, we find way too many. Way too many. Oh, we need to do the inverse, right? Where not parsing. Yeah, there we got it. Is that like unique? Union. Oh, well, it's good enough. Nice. So now we found all the 2 files, the operator resolver and the progress resolver that don't have the authorized file. I also want to like have nicer output. I want to now like just get the string or something so I can copy and paste it over to my notes document, you know? But that was pretty cool. I mean, so my problem, especially like this TypeScript Java. Okay, I guess maybe it's time for a conclusion or something. We had a research question. The research question is,